Welcome to Lesson 1, Properties of Perpendicular Bisectors. Our objectives today are to identify the properties of perpendicular bisectors and use them to solve problems. You'll notice here we have an example of a perpendicular bisector CD that's bisecting line segment AB. Let's go ahead and talk about some of these properties. Okay, number one, angle made between a perpendicular bisector and the side forms a right angle. So this perpendicular bisector CD forms a right angle with this side AB, this line segment. And you can see the right angle here marked in blue. That means that next to it, we must have another right angle right here. Okay, number 2. Perpendicular bisector bisects the line segment into two congruent pieces. So, as its name said, it's perpendicular, therefore we have the right angles, and it's a bisector. It's bisecting AD into two congruent segments that you can see with these congruency marks. So I could write that AD is congruent to BD. Finally, here's the big point. Number 3. Any point on the perpendicular bisector will be equidistant from either endpoint. What does that mean? That means if I take point D here, which is on the perpendicular bisector, it is equidistant from A as it is from B. So for example, if the distance from A to D was 5, well then the distance from D to B would also have to be 5. But we can take this idea and we can apply it to any point on the perpendicular bisector. Like I could make point E, for example, right here. And if I made point E, then the distance from AE, drawn like this, to EB, drawn like that, would also have to be congruent. So this AE would be congruent to BE over here. I could carry that even further and I could look at point C up here and I could say, well, then the distance from AC right here is going to be the same distance as it is to AB right here. And I can make some congruency marks. So if AC is 20, then CB is also 20. Can you see what kinds of triangles that I'm making with these lines? If you said isosceles, you're exactly correct. Any isosceles triangle has two sides that are the same. It has exactly two sides that are the same. So in this pink triangle, AE is congruent to EB. In this green triangle, AC is congruent to CB. So in an isosceles triangle, the distance from the vertex, the top of the triangle, down to the opposite side is always going to be a perpendicular bisector. Let's try some examples now. Here's an example. Now I know this is a perpendicular bisector because I can see that AB is congruent to BD by these congruency marks, and I can see my right angle here. So what that tells me is that B is equidistant from A as it is from D. Therefore, that I know that AB is going to be congruent to DB. So I can take my two measures if I want to solve for x, and I can say that 9x minus 2 will have to be equal to 7x plus 10. And then I can solve for x. I can subtract 7x from both sides and get 2x. Then I can add 2 to both sides. And I can get 2x equals 12. And finally, I can divide by 2 both sides. And I can get x equals 6. 12 divided by 2 is 6. Then if I needed to find the length of these segments, I can just substitute 6 in here for x. So if I were to do that on this first one, I would have 7 times 6 plus 10. 7 times 6 is 42, and then 42 plus 10 would give me a side length of 52. Since I know that both these sides are congruent because of the theorem, I know that 9x minus 2 will have to equal 52 as well. I can test that out by plugging in 6. 9 times 6 is 54, and 54 minus 2 is 52. Let's try another example. Okay, so in this example, we are going to assume, because it's not stated, that this is a perpendicular bisector. Therefore, this forms a right angle, and this side is congruent to this side, because we have bisected we'll call this A, we'll call this B, and we'll call this C. So what I want to find is the length of side DA and the length of side DC. Well, I already know what that's going to be, right? If this is in fact a perpendicular bisector, then I know that this side is going to be congruent to this side, because any point on my perpendicular bisector is equidistant from the endpoints A and C. So that means 2x plus 1 is 45. So if I wanted to know what x was, then I could just say that 2x plus 1 equals 45, and then I can solve for x by subtracting 1 from both sides, and then dividing both sides by 2 to get 22. So x would have to be 22. And I can check my work by plugging that back in. 2 times 22 is 44, and 44 plus 1 is in fact 45. Let's try one more example. Okay, in this example, our triangle is marked. We know that this is a perpendicular bisector, so we know BD is the perpendicular bisector because we have a right angle and we have congruency marks. Well, this time we don't know what any of the sides are because we're not given any measurements. But we do know that side AB right here has to be congruent to side CB over here. So we can set our two sides equal to each other because in fact they are. And then we can solve. I can subtract 4x from this side and 4x from this side to combine my x's. So I'm left with 10x minus 10 equals 0. I can add 10 to the other side and get 2x equals 10. And finally, I can divide by 2. And then I find that x is equal to 5. Now I know what x is. If I want, I can plug in x here or here because I should get the same answer, and I can figure out what the side lengths are. So if I plug in 5 for x, I would have 4 times 5. That equals 20. So I know this side equals 20, and I can test it here too. 6 times 5 is 30, and 30 minus 10 does in fact equal 20. And that concludes our lesson today on properties of perpendicular bisectors. So hopefully you will remember these 3 properties or write them down in your notes. That you have a perpendicular bisector if the angle made between the perpendicular and the opposite side forms 90 degrees or a right angle. And the perpendicular bisector then bisects the side that it intersects with. And then finally, any point on the perpendicular bisector will always be equidistant from either endpoint.